Coming up on This Week in Radio Tech, forget everything you learned back in the late 80s or early 90s about single frequency networks or FM boosters. It's all changed, and it's all better. In fact, it's nearly perfect. We got Rich Redmond and Bert Goldman on This Week in Radio Tech next. This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support. Online at bgs.cc. By Broadcast Bionics with the Bionics Studio, including talk show control, social media, and visual radio. Broadcast Bionics brings exceptional audience engagement to radio and TV. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. By Nautel, worry-free transmission you can count on with outstanding control, reliability, efficiencies, and Nautel's unmatched 24/7 customer support. Online at nautel.com. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts. Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to that light bulb at the top of the tower. I'm Kirk Harnack in the Telos Alliance studio in Nashville, Tennessee. Glad to have you along. We're going to talk about some interesting things for FM broadcasting. That it's a topic where I'll just say that a lot of us engineers think we know what we're talking about with this. We already have some preconceived ideas, but unless you have dealt with this yourself and recently, you may not know what you're talking about. So let's get into it shortly. I want to bring in my co-host from Muckwonago, Wisconsin. It's Chris Tarr. Hey, Chris, good to see you.
Hey there, Kirk. I'm in the Louis the Dog studio. You have the Telos Alliance studio. I have the Louis the Dog studio. Just got back from an exciting day of we're installing a new transmitter at one of my sites. So just turned the power on to a brand new Nautel 30 kilowatt transmitter. It was exciting. It was nothing like the smell of a brand new transmitter.
What, 30 kilowatt FM transmitter? That's the TPO?
No, that's the size of the transmitter. TPO is going to be less than that. It's
okay.
FM and HD.
Oh, so you're not running it. Oh, gotcha. It's FM and HD. Yeah. So the FM's going to be a little bit less.
It's country and Western. So.
Yeah. Gosh. Oh, gosh. Speaking of country and Western, now that really wasn't a segue. Our show's brought to you in part by Ray Top over at Radio Guide. Ray, I always thank you for great guest ideas and great in-depth articles in Radio Guide. One of the differences about Radio Guide magazine is that Ray Top, the publisher, has room to publish longer articles so that they can cover more engineering articles, more in-depth in Radio Guide magazine. To get Radio Guide, go to radio-guide.com, radio-guide.com. You can view it online or you can sign up to get your paper copy like I do. We got to take a quick announcement right here before I bring my guests in, because our guests have some complicated stuff to talk about. At least I think it's complicated. They're going to tell us how simple it is. And we want to have full amount of time with them. So we're going to go ahead and hear real quickly from our friends at Nautel. Nautel puts together this Transmission Talk Tuesday every Tuesday this month. And Jeff Welton is the host. And here's a quick tip from Jeff Welton from a previous show.
Steve Schoen has asked, is it okay to use an LM34 to monitor outdoor temperature? And if so, how do you protect it from the elements? Josh, have you dealt with that?
Yeah, there are certain board designs. I think CircuitWorks made one that had an LM34 and a few other devices on it. Typically, when we've had to do those outside, we would try to do them in some sort of like a plastic project box or something along those lines, just to make sure that it was sealed up. You know, you have to put it in, but then you got to seal it up real tight with silicone or some kind of a sealing grommet or something like that. And don't use a black box. I had a station that did that. They rolled their own temperature sensor and stuck it outside in a black box, and 75-degree day, and it was reading 110. Oh, it's so hot. I'm like, it's not. You change it. Typically, the other thing that we recommend is on the bottom, drill some holes. If you mount it on a wall, make sure you drill some holes in the bottom, because you'll have condensation in there, and eventually it will fill it up. Not to mention the humidity of the condensation evaporating inside the box is going to corrode your components. So drill a couple of weep holes in the bottom.
Sort of a sidetrack. I walked into a site in Florida once, outside of Largo, near Orlando, and they were off the air, and we're troubleshooting, and the AC, they kept tripping the breaker. And I mean, what's going on? So walk outside, there's a NEMA box on the outside, one of our surge protectors, which are not really meant to be installed outside. I opened the door and it let about 4 inches of water out of the box.
There's your problem.
So yeah.
So you'll hear all kinds of advice like that, and even better advice on Transmission Talk Tuesdays. It's a roundtable event where you get to participate if you want to. Go to nautel.com/webinars to sign up. And you can sign up for several at the same time. So it's real convenient just to sign yourself up. They'll send you a little email a day before and an hour before to remind you about the webinar. Thanks, Nautel, at nautel.com/webinars. All right, let's bring in our guests. We have a couple of guests today. One of them, our first guest, is Bert Goldman, who is president of Goldman Engineering Management. And it turns out that Bert and I have crossed paths almost several times. Bert, welcome in. It's good to see you.
Thank you. Good to be here.
Bert, yeah, you're going to be talking with us with your partner in crime here, Rich Redmond. We'll bring Rich on in just a second about this. What you tell us? What's the elevator pitch about what you're going to be talking about today?
You're asking me?
Yeah, Bert. Yeah.
We're talking about synchronous boosters, the ability to have an on-channel booster within your protected contour and seamlessly transition between the main and the booster without any interference between the two. It's a technology that wasn't really even available 5 years ago, but
yeah,
it's available now.
That this is really cool. Rich Redmond is here too. Rich, you are the founder of and managing partner over at, and pronounce it for me. Is it Strativa? How do you say your company?
Strativa.
Okay.
Strativa. Yep.
Good to have you here. Welcome in. Good to see you.
Thanks.
Thanks. What is Rich? What's your relation? Now, I know you're a technical guy. You've done technical, talks with people all around the world, especially in your previous role with Gates Air.
Right.
What's your relationship with Bert and Bert's companies?
Yeah. So in this scenario, Bert and I both work with a company called Geo Broadcast Solutions, which has developed some technology around implementing FM boosters for the delivery of seamless coverage expansion. So really, if we've done some math and figured out that almost 80% of the FM stations in the U.S. have some area within their licensed contour that they're getting subpar coverage, either terrain blockage, could be from large buildings in a city, or some other such limitations, interference, co-channel or adjacent channel interference, that just makes it really hard for people to listen to the programming in part of their coverage area, and that's what Geo Broadcast has some solutions for.
So I'm going to just set this up simply by saying that my own experience, but it's not hands-on experience. It's it's reading, it's listening to other people, it's seeing posts and forums over the last literally 25 or 30 years. My own experience has been that on-channel boosters can help you in just exactly the right circumstances, but you're going to have this big interference area, and unless you maintain it exactly right, things are going to go wrong. It's not good. And you guys, I think, have a real answer to this now. As Bert said, the technology in just the last 5 years has gotten to the point where you can do this basically perfectly. So I'm with that. My impression hopefully is wrong. Tell me where I'm wrong, and tell me what you're talking about doing here. And hey, Rich and Bert, please feel welcome to call out for any of the slides that Suncast has ready. And Chris, feel welcome to chime in with a question or comment of your own. I'm gonna shut up until I feel like I need to oh, there we all are. Look at that. Oh, hey, look at Suncast made a four box here. That's pretty
We're
sexy.
All there.
Suncast.
It's almost
right.
the Brady Bunch.
That's right. That's right. We just need a few more.
Right. Where's Alice in the middle? So maybe I'll take a start at the high level. I think Kirk, your impression, until recently has been pretty accurate. I mean, I remember when I first learned what an FM booster was, I'm like, well, geez, why doesn't every FM station use this? They all have a place you could go fill in. And, one of my early mentors explained to me, well, that's because they don't really work very well. And, so the concept always was you could license a booster or boosters within your contour, your protected contour, the exact contour changes by station class, but with up to 20% of the class power. So if you were a class B station, you could put another transmitter somewhere in your contour up to 10 kilowatts ERP. Well, the challenge is most of us who, any engineers who've been good at placing and building FM stations, what are the things you always look for? Well, I want some really tall site with a great look angle on as many people as I can see. I ideally want to run as much power as I can, probably putting the power in every direction that I can go. And those are kind of exactly the opposite of what you want with a booster. I kind of make the analogy that, if you think of lighting up a football stadium, if we did it the way we normally broadcast FM radio, we would put the sun directly over the stadium. And so it would be really bright, but of course, you would have light going everywhere. Instead, you light the stadium by having very directive lights that are very focused down on the field and not so much throwing light into the neighbors. And so that kind of high level concept is the thought that takes us to, this next generation of FM boosters, which really takes a number of things. Some is RF network design, and Bert will go a little bit into the details there, but at the high level, I would say it's taking the type of planning tools that aren't used in radio, but rather are used for mobile phone networks. Because if you think about it, there's a lot of frequency reuse there, and they have to figure out how your phone works in the elevator inside a building and things like that. Very directional FM antennas, digital, either, analog digitally derived or HD radio, low power transmitters, and hyper accurate GPS synchronized and time delayed audio distribution. So those are kind of the products that became available, but it's this mix of having the right products from, a number of reputable vendors and this kind of secret sauce of network planning that's been figured out over, a lot of time and investment over the past 10 years by the Geo guys.
So if I could add a comment. So when we do an on-channel booster, we're transmitting the same audio at hopefully exactly the same modulation level in perfect sync with the main channel, so that when a receiver goes through the main coverage area into the booster's coverage area, there's a minimum of interference or time when it's kind of receiving both at the same time. Now, helping the situation, and a lot of us are aware of this capture effect that FM receivers typically exhibit. So as long as there's some difference in the RF level of the two signals, the receiver will lock onto one or lock onto the other, and largely, not necessarily entirely, but largely ignore the other one. And that's a characteristic of the FM reception system, the way FM reception works. So that works to our benefit. And so now we don't have any control over how much capture effect that a given receiver has. So I'm going to want to try to understand what are the other things that we can control. And I don't mean to call your slides out for you, but I think your first slide may actually list some things that are important for the characteristics of the booster.
So the idea is to fake out the receiver into thinking it's listening to the same transmitter. That's what it comes down to.
Yeah.
So starting off the slide, there's a bunch of things that we have to think about in order to fake out the transmitter. Basically, it has to think it's looking at the same carrier and the same pilot, and the way we can do that is by GPS locking the carrier and the pilot and keeping the timing identical, so that all of the RF gets to the receiver at the same exact instant in time within a microsecond or two. We have to keep the pilot phase exactly matched. Modulation has to be within 1/4 of a dB, or else the one or the other of the receivers, when it's going back and forth, will pick it up as distortion. And obviously the difference is, the more distortion there is. We use digital composite now because obviously we're able to match the carrier, the pilot phase, the modulation, pretty much everything except the timing is perfectly matched with the digital composite. The timing is extremely critical because even though RF propagates at the speed of light, it can be many multiples of microseconds different. And we found through our testing that if you get more than about 3 to 5 microseconds off, that's going to look like a different radio station to the receiver. So it could be 10 microseconds off, or it could be 10 minutes off. The receiver is going to see 2 different signals. So that's one of the things that we have to be real careful about. The antenna has to be designed in such a way that you don't exceed that 3 to 5 microsecond limit. So going between one and the other, you can't use non-directional because, as I'll show you in a minute here, you create interference by exceeding that 3 to 5 microsecond difference. So let's go to number 2 real quick.
Slide
and try to go through these pretty quick here because I don't want anyone to do death by PowerPoint today. But in the upper left, we're looking at a non-directional, fully synchronized but non-directional antenna on a booster, which is to the right. The main is off to the left. The magenta is where there's interference. That's based on subjective testing, where Geo's determined that less than 90% of the listeners would put up with it. So that's a lot of magenta. If you look at the slide directly under that, you can see that if you use these directional antennas and have everything perfectly synchronized, there's no interference, no magenta. In the upper right, if you're only off by 10 microseconds, that's all the interference you generate. It's got to be pretty precise. And since we can't use a lot of power, everybody wants to put more power in, but we found that if you go with too much power, you create more interference for yourself. I have those in some other slides that I won't bore you with today, but we use multiple boosters instead to cover a larger area. That we can synchronize, that we have control of. So that's how that works.
I'm guessing here that the main transmitter side way off to the left, that's where the transmitter has to be. But I'm guessing here that the area of, let's say, financial or population interest is more to the right. Is that correct?
Yeah, this happens to be Chicago, and
I thought so.
Okay. Those boosters cover central Chicago and the freeways leading up to it. So areas that were essentially unlistenable prior to the boosters being installed.
So with those lower pitches, with no magenta, you mean I can drive a car through those areas between the main and the booster, and I'm really not going to hear it go between the two?
That's right. And what we found is the only way we could tell is that we put different static RDS on each booster so that when we go from one to the other, we can see which booster by looking at the static RDS.
Yeah,
so it's really pretty incredible.
It's, I think I would say, Kirk, I kind of went, I even having doing a number of these, kind of went in thinking there's going to be a certain amount of interference, and these actually perform a lot better than even I had anticipated. The predictions,
they performed better than I thought they would. Yeah. I mean, you have to understand that there's been a lot of research and development and specialized software and everything. It's not the nuts and the bolts themselves that make it work. It's the design, which is what Geo is really refined to the point of making it work so well.
I want to hear more about this in just a second, but we got two things to do. We're going to take a quick commercial break. But a lot of us engineers first heard of FM synchronous boosters back in the mid to late 1980s, and the company TFT had a system out called the Reciter that used some kind of multiple of the pilot to try to get the modulation the same. And it was interesting, but I think it was way inadequate, and you ended up with large areas of interference, which is where people like me got their attitude about FM boosters. But of course, when you can do this in the digital domain, you can reproduce it perfectly, and you can time it exactly the way you want to. And I guess that's a good part of the secret sauce that you guys are putting to use here. Would that be right?
Yeah, TFT had the right idea. They were along the right idea. They just didn't have all the pieces and parts included, like in particular the time delay, and to a certain extent the phase stability and and the modulation wasn't quite perfect, but it was close. It was pretty darn close.
And this was
Yeah.
kind of a this is kind of I'm guessing an outgrowth of the synchrocasting from Big City Radio all those years ago, where they were taking interplexes and delaying them and that sort of thing. Of course, back then the technology wasn't nearly as good as it is now, and you could hear as you're driving from one zone to another, you could hear the pilot phase changing, and you could kind of heard changes as you went from signal to signal. But it sounds like that was almost like at that time that was the best you could do with technology. It sounds like it's greatly improved now because you're able to model and you're able to use different sorts of antennas and things like that. So really, this is really well refined. Is basically what that is.
The problem also with the big city theory basically is that when you have different radio stations that they're assigned a circular coverage area, you can't direct the signal away. So you're going to wind up, there's no way to avoid having an overlap and an interference zone similar to that first slide that I showed there.
What I think too, the other issue you're running into is, different with different even just transmission systems, antennas, feed line. You can compensate for time delay. It's very hard to, factor in, velocity factors of lines and all these other things that back then were a lot harder problem to solve than they are now in terms of, with just the brain power and the computing power we have now.
Well, to that
exactly.
point, to that point, you have to make these work the exact same model and the exact same firmware load on every exciter that you use, because even a different firmware load on an exciter can change the throughput time on the exciter and some of the other characteristics. And even though you're feeding everything perfectly, you still wind up with a disparity by having something that's unsynchronized going on within the exciters. So that's the level of detail we have to watch out for.
As we're going to take a
go
quick
ahead.
break here. Hey, Chris, we'll have to finish that thought after a quick break. Camera one, we're going to talk about the geocaching part of this in a little bit, how you can, send pretty much almost directed messages. And that's might play into your social media plans for your radio station. Well, check out this from Camera One. It's their multi-camera Camera One system from Broadcast Bionics.
Camera One from Broadcast Bionics. Designed to bring video to your audio content, visualizing radio and podcasts for social media. Camera One can automatically create, capture and brand professionally switched video for live streaming or upload, making your production shareable. Control and configure using a web browser on any device. Camera One is available as a 4-camera or 8-camera system using the Blackmagic A10 Mini range, including the A10 Mini Extreme. You can use cameras to suit your studio and your budget. You'll need one camera for a studio wide shot and usually one camera per microphone. A standard multi-channel sound card or IP driver monitors audio from each studio microphone, and we work natively with Axia systems. Ideally, this will be a post-fader feed from each mic, although you can use pre-fade audio or a mic split if that's all you have available. These audio levels are used to intelligently switch the video feed when each contributor is talking. You can also group microphones together into one shot and use the audio from a mixer's aux bus. You can use Camera One's auto switch feature, or disable it and switch using the on-screen buttons or the buttons on the A10. Recordings can automatically start when you tell the system you're on the air. This on-air indication can be linked to your studio's red lights via IP or an Avantec ADAM GPIO interface. You can quickly browse all the videos that have been automatically created during your broadcast, download them and post. Camera One is a user-installable system. You'll need a good spec Windows 10 PC, i7 with plenty of storage and 16 gig of RAM. It's better if this machine isn't used for anything else. Remember, you can control the software in a web browser on another device on your network. Camera One, a thrifty way of creating scroll-stopping video from your show or podcast from Broadcast Bionics.
And the way you find out more about it is to go to their website at bionic.radio. Yeah, .radio is a top-level domain. So go to bionic.radio, check out the Camera One system, and thank you, Broadcast Bionics, for sponsoring This Week in Radio Tech. Our guests today, along with Chris Tarr, my co-host, Rich Redmond is here, and so is Bert Goldman, and they are here to keep filling us in on FM boosters and how the technology has gotten to where it's basically seamless. So, Bert, you want to continue where we left? Oh, I'm sorry. Chris was in the middle of asking a question, and then we'll continue with Bert's presentation.
I think I asked my question.
Okay.
Yeah,
we're
think
talking about the history. Yeah.
Yeah, it might have been me, Kirk, and I guess the thing I was going to say is, Chris was mentioning about, the old days of big city radio and the fact we had a bunch of omni stations. What we ended up finding is a lot of these problems have been solved, albeit for narrowband broadcasting in land mobile radio. So police and fire use single frequency networks where they have to have a bunch of these transmitters around a city. They have to have high enough power so that, if I'm the fireman in the burning building, my handy-talkie works, right? And so the Motorola guys who, there's been a whole cadre of Motorola engineers involved with Geo Broadcast, really kind of help bring some of that technology and approach to both manage where the RF signal goes and then managing the audio timing. So it's kind of really looking beyond the big city radio is kind of taking what we know about FM radio stations and trying to take it to the next step. What's happened with Geo has kind of been trying to pull from some other industries to help, get some best practices.
Gotcha. Bert, are we ready for slide 3, or where do you want to go now?
Sure. Let's. I'm going to try to go through these a little faster now, but this is an example of what's going on in San Francisco right now with a booster that was put on the air on Mount Diablo back when they first deregulated boosters in the late 80s. And it does a pretty good job of covering the area that the San Francisco stations don't cover. What they don't tell you, though, is that it creates a ton of interference, not only in the East Bay, but it shoots over the East Bay hills. And on the lower part there, you can see that there's 800 some odd thousand people that are getting interference. In the late 80s, nobody cared about covering the Silicon Valley. Well, now it's a different story. So let's move on to the next slide here. And you can see another example of that same thing. The problem is that the booster is pointing right back toward the main. So it creates all that interference. Now let's go to the next slide. And you can see what the Geo design is, which we're about 3/4 of the way finished installing this for 3 stations owned by Bonneville. It's on 5 different booster sites. We have boosters within boosters and everything else, but you can see the limited interference. The interference essentially goes away. It blows out into the delta that's unpopulated and down into a park area down to the south there. And that's pretty much it. We pick up between the loss of interference and the addition of people about 1 million listeners, which
oh my goodness!
So it's pretty significant.
Wow.
So any questions so far?
And I mean, look, I'll be Mr. Skeptic here. Anybody can draw circles on maps. You've borne this out with driving around, listening, and I mean, this customer's happy.
Yeah. So let's go on to the next slide, and I'll go over that.
Okay.
So that's exactly the point. This shows you what we do in order to make sure that this stuff works as advertised. We certainly don't use Longley Rice. That isn't even close to accurate enough. The software we used is called ATDI ICS Telecom. This is the stuff that T-Mobile and AT&T and all of them used to develop their propagation. We had some custom work done to match the propagation in the FM band. And the propagation models that we use is ITU 525, 526 with Daegu diffraction. I don't know if I pronounced that right. And subpath and ground reflection. So it's a big mouthful, but by doing that and feeding field test from our Automat MC5, which you see the output down there on the lower left, and then you see the yellow squiggly lines up there to the right. That is a correlation model between the propagation output from the software and the field testing. And you probably can't see down that low, but the fact is that the correlation as determined by the software is better than 95%. So we know darn well that whatever we are proposing is going to work as advertised in the field.
Wow.
So to show you how detailed the mapping is, let's go on to the next slide there. This is what we did in Boston. You can see the blue and the white is virtually no signal before we put in boosters. On the right, that's the signal afterwards. So you have in-building listening and car listening in that entire area in central Boston where you really couldn't hear the station before. The signal's good enough that the tunnel has now picked the station up. So you can hear it seamlessly in the tunnels and outside the tunnels in all of central Boston. And WXLO, as you might expect, has had a significant ratings and revenue increase by having that stuff. So moving on to the next slide, this is the level of detail. The lower left, or the left there, is the main only. If you can look down into that picture and you can see the signal level is plotted in every street, on every street corner, down to, the guy walking on the street. It's extremely detailed and extremely accurate, and even the buildings are figured into the calculations shown here. On the right, you can see what it looks like when the booster is turned on. So it's a pretty significant detail that we work with, and we've been able to prove that it bears out exactly as we predicted.
So now they can even hear them give the legal ID of Worcester, even in Harvard Square.
Exactly.
Yeah.
Sorry, that was a really, really bad. I'm sorry, Boston. That was terrible. Wow. And I take it those red and yellow areas. That's pretty good signal area. That's some building penetration there, and that wasn't there before.
Yeah, anything from light green up to yellow and red. Yellow and red is certainly building penetration. Sure. Yeah. So people that couldn't even hear the station can now hear it in the offices. And we've done drive tests.
In the San Francisco Bonneville example, you said they picked up about 1 million more potential listeners. Any idea what it was in Boston in terms of more potential?
That's about
similar.
It was over 1 million, actually. Yeah.
Oh,
yeah.
Okay.
Yeah, over 1 million. And I think one of the things that's really applicable is for stations that are in PPM rated markets. There's a direct correlation between RF signal and the ability to decode on the PPM meters. And so we've got some tools where we can test it. And what we often find in these poor areas is before only 1 or 2 of the messages get through, I think there are 12 messages a minute in PPM. And as the signal level gets improved, the number of decoded messages goes up significantly. And so the stations that have implemented it have similarly seen, either new listeners, or they're actually getting credit for the listeners who were listening through static before, but the meters didn't properly register.
Yeah, in all of these larger markets, we run the audio through a TVC 1.5 and do a before run and an after run so that we can show graphically the improvement in the percentage of PPM recovery.
And for those who don't know, a TVC 1.5 is a product that's manufactured by my employer, TELUS Alliance, and it's a PPM receiver that shows you every 400 milliseconds. It gives you a new reading of, am I picking up the PPM or not? So it's not an idiot light that is on or off every 2 minutes or so, like what you may have or maybe supplied to you by Nielsen or Arbitron in the past. But it really gives you almost a real time reading. of what's going on. And you can you can plug a microphone into the input of it and ride around in your car with a microphone and the radio turned up to see what the reception is like in real conditions. Um, I, Bert, I want you to continue on, but I've got a question, and maybe now's not the right time to answer it. So if now's not the right time, just say noted. I'll answer that at the end. How does a radio station, how does an engineer work with management to figure out, is this technology applicable to my particular situation? You've shown us two rather difficult situations, San Francisco and Boston. And if you're a rim shot and you want to hit the area of financial, there's always the city of license, and then there's the city of financial interest, right?
Right.
And so I think it's sure rim shots may be prime for this, but in San Francisco that wasn't a rim shot. They're right there in San Francisco, but they got all this population outside. How do you start to have that conversation about, is this a technology that is going to help us out a lot?
Well, I think if your station isn't located, if the main transmitter isn't located in very near to or in the middle of your area of financial interest, as you put it, chances are something like this can be of assistance. Any of the rim shot type facilities, there are a lot around Dallas, Houston, all over the place where you have these rim shots, and you don't quite fill out that 60 dBu, but the people you want to cover are in the 60 dBu. That's where something like this can really help. We don't charge to do a first look anyway. So,
I mean, here's a great example of a smaller area that's not a metro that could use that, because we've kind of tossed it around a few times. Is I've got I think it's a C2 up north, and the market is La Crosse, and the tower is in a little town called Sparta, but La Crosse is down along the Mississippi River, so it's in this valley. Well, our signal on the other side of La Crosse is great when you get out of the valley. The signal on the side coming into La Crosse is great, but in La Crosse, the signal's very poor, and it's in our 60 dBu contour, but because it's in this valley, there's a lot of multipath issues. There's places where the signal just disappears. So, there are situations like that where it's not even a matter of financial interest in as much as it's our signal, and we should be able to have hear the radio station there, and we don't. So, there are also there are also instances where smaller stations are looking at something like this just to overcome land issues, the terrain issues.
Yeah, we've had situations. Absolutely, we've had situations even with a little Class A up along the Great Lakes that are getting hammered by a grandfathered Class B in Grand Rapids, and going all the way across the lake in the summer and blowing them off the air, basically. And we didn't implement anything, but we had a full design to essentially override the interfering signal along the shoreline there, so that their listeners could actually hear their station in their city of license.
Yeah, I think, Chris, we've done a system in West Virginia for West Virginia Radio, and it's very much like you described. It's not a big market, but the contour covers, there's areas of interest in there, and because of terrain, there's some valleys where on either side it comes in great, but down in the valley not so good. And so we've implemented some boosters for them, and so while the financial payoff, look, the big markets are have a significant advertising revenue, this technology scales to really any size market. It's a pretty powerful tool.
We're gonna continue with this discussion on This Week in Radio Tech, episode 585. Bert Goldman and Rich Redmond are both here, along with Chris Tarr. I'm Kirk Harnack. Our show's brought to you in part by Hank Landsberg over at Henry Engineering. You've probably installed some of those Henry super relays throughout your career. I know I've got a bunch of them in my radio stations, and I run across them all the time. This is the replacement for that, or if you're using LEDs to run your tally light, your on-air warning light, maybe your light on your microphone stand, this is the box to use. The Henry Super Light, as I call it, kind of like WNBC, the Henry Super Light. It's really a convenient box. Instead of building up your own circuit to switch the LEDs on and off, to make them flash if you want to make them flash, and to program an address into these so you can daisy chain several of them together, just get the Henry Super Light. Of course, it'll run your LEDs. That's built in. It's got a power supply that comes in the box. You can also provide your own external power if you have more LEDs to run. The specs are all in here that you can, how many that you can run. But it also has some extra relays. It does, of course, have some normally open and normally closed relay outputs. So if you still have a cassette deck for scoping your air checks, yes, you can control the capstan motor on that. No, but seriously, if you're using a console that doesn't mute the speakers, you can use these contacts to mute the speakers. All kinds of different things that you can use them for. So you've got, again, flashing on there. You can control LEDs on it, and you've got this extra contacts to make that happen. And you can control it with a DC voltage or with a ground closure. Either way, the Henry Superlight will do that. And if you're watching on our video on our podcast here, you can see in the lower right-hand corner an example of hooking up up to four Henry Superlights just by daisy chaining them together. And you can set a little jumper inside to set the address. And maybe you've got all your on-air lights all contained in your rack room. It's just an easy way to string them together if you want to do that. And those connect with RJ45 connectors and Cat5 cables. So that makes that pretty smart. The Henry Superlight, it's your great replacement for the Henry Super Relay. And check out all the Henry items. I mean, Hank Landsberg makes a variety of things that are great for your radio station, podcast studio, even your TV station. He's got accessories that'll help you out and make those things go a lot quicker. And when you want to buy a Henry Super Relay or just get a quote, or how soon can it be delivered, or get some ideas on what else Hank Landsberg makes and sells, call my friends at Broadcasters General Store. Their website is bgs.cc, but you can do what I do and pick up the phone. They are there. They're not there 24/7, but I tell you what, every time I call them, they're there. I get somebody on the phone right away at 352-622-7700. I used to have that number in my little black book of numbers, and I've memorized it over the years, called it so much, buying different broadcast equipment. 352-622-7700 for Broadcasters General Store. Thanks a lot, Hank Landsberg, and thanks to BGS, Broadcasters General Store, for sponsoring This Week in Radio Tech. All right, Chris Tarr is here, and we are pleasured to have Bert Goldman with us and Rich Redmond as well. And tell you what, Bert, why don't you go on with your presentation? I think we've got another slide up ready to go. And then I do have a question about building a large building causing a lack of signal along an interstate highway. And maybe you can see if that would be a good situation for an on-channel booster. But Bert, take it away.
All right, just one more example of what we've worked on. This is the fan in San Diego, and it's a Odyssey station. And as you can see, that some highly populated areas up to the north are getting zero coverage on the left there. And by adding our boosters, you see there on the right, we are able to pretty much fully cover the populated areas. The area in the middle there on the top is completely unpopulated, so we didn't bother to cover that with boosters. What's interesting about this is on the right-hand slide, on the lower one there, you can see FM1. The owner of the Padres gets his own booster because he can't hear it in his house.
Of course he does.
Yeah. Right.
Why wouldn't he?
It's exactly as Chris said, right? It's well within the contour, but I guess where he lives is in just enough of a decline or a crevice or a valley there that when he's in his yard, he wants to hear the baseball game.
That's right. So the last slide I got here is this is the first station we did. We've done, I think, 3 or 4 now, HD main and HD boosters. This was our first one, and took a little bit of tweaking on things with both the Xperi folks and the Gates Air folks to make it work properly. But it's working properly, and it's working great. slide on the left there, or the picture on the left, shows how bad the HD recovery was before we put the HD on the boosters. And as you can see there on the right, when we turn on the boosters, we have full recovery. The only issue that we have right now, and they're working on that, is that there is about a few second dropout when you go from one HD stream to the next, but it just, HD1 folds back to mono, and HD2 just interrupts for just a couple of seconds as it's making that transition. But as you can see, it's pretty darn seamless and way better coverage for a lot of people up there in the north part of the San Diego area. That's all the slides now.
That's fascinating. Okay, so here was my question. Years ago, this would have been back in the late 1980s. Late 1980s. I worked at a station in Memphis. It's a Class A. It was licensed to Germantown, Tennessee. I don't know if they've moved their transmitter since this time, but there was a section of the interstate that loops around Memphis. There was a section, a good 6 or 7 miles of it, where the station would just tear up just terribly. The reception was awful along this area, and couldn't figure out why. I mean, was there an interfering signal? I didn't have a spectrum analyzer at the time, and I didn't really have a great way to coordinate looking into that. So one day I'm driving around, and I noticed that there's a great big hotel along the south side of the interstate, and the hotel was situated such that it was flat to the signal. In other words, this transmitter was over here, and the interstate of interest was over there. And I didn't know how straight it was along the interference, along the shadowed area. But this hotel shadowed the interstate. So I went down to the Army Corps of Engineers office, and I bought some topo maps, and I got out a ruler, and I started plotting things out and where the hotel was, which the hotel was actually on the map. And I realized that, well, I don't know if this is the cause, but that whole section of interstate, that where you have bad reception, exactly matches where the signal is shadowed. Now, it's a Class A, so it was only 328 feet up in the air, thereabouts, and the hotel was reasonably tall. And so I just figured that, well, that hotel is actually shadowing the interstate. Is that crazy? And if it's not crazy, could a booster these days be put maybe on the roof of that hotel and cover the area that's being shadowed?
The answer to that is definitely, to give you an idea, we've looked at how much buildings attenuate the signal. And just to give you an idea of how much attenuation there is, if you are shooting an FM signal from New Jersey onto Long Island through Manhattan, your signal will go down by 20 dB. So if you had a 60 dBu signal, perfectly good signal on the left side, on the right side in Long Island, it will be unlistenable. And that's what's happening to some of the stations that are coming in from New Jersey. So even though it's inside their contour, absolutely. And I think that I've looked at that Georgetown station. I sure remember something like that. But
what convinced me was the lines that I drew. Okay, where the shadow started on the interstate and where it ended matched the shadowing exactly from the point source of the transmitter to the width, taking into account the width of the hotel on the topo map. Wow, within a few hundred feet, it absolutely matched. Now you get farther away and you get more scatter, and the signal actually got better farther away because it was just more of a scattered signal.
Yeah, right. These things aren't cheap, so we have to think about the cost too. What were you going to say, Rich? I'm sorry.
Yeah, I was just going to say, actually, when we look at the, because the network planning software takes into account the 3D modeling of the buildings. So we were doing one in Toronto the other day, and you could see, even frankly from the booster, Kirk, where we were filling in, you could see, because there were some adjacent buildings that were quite tall, it was exactly as you described. There was a notch that this building was creating on the propagation. And so, you're 100% correct. The building attenuation can actually be very significant. The good news is, we can understand that by looking at the modeling and then plan the network around it.
Well, I mean, and frankly, had this station been a Class B or a C, if it had a little taller tower, this probably wouldn't have been an issue, or just for a very short
Yeah.
bit of interstate. But the angles there were just right to block, a whole bunch of interstate.
Yeah,
Bert,
exactly.
you came to the end of what you're talking about there. What else would we want to know about the technologies involved here? We talked very briefly about that early on, about how it's an MPX signal carried digitally over some Gates Air equipment. Is that right?
Yeah, it doesn't have to be necessarily Gates Air, but it does need to be able to adjust the timing. And we found that the digital composite is really the best way to do it. Gates Air has a complete package to do that. I think there are maybe one or two other manufacturers in the world that have it, but this is what we've used it on and tested it with. As far as transmitters and exciters, we've used Gates Air and Nautel with no problem. And again, as I say, you have to be fully same exact exciter on the main and the boosters, same firmware and everything. And we're using dual log periodic antennas for a narrow beam in most installations. Sometimes we can use a panel depending on the application. And there's really not a whole lot of other pieces and parts that are involved in the process, other than the design and the modeling. And by the way, the IP network has to be very stable, by the way, especially if you're doing HD. That tends to be our weakest link.
That brings up two questions. You mentioned you had some HD in one of the examples you showed. Is HD typically part of this geo broadcasting, this max casting solution, or typically not part?
Well, if you want it, yes. I mean, it's up to the customer as to whether they want to have HD on their boosters. They can have HD main and analog boosters. They can have analog main and boosters, HD main and booster, whatever combination they'd like. Obviously, when you have HD on boosters, it gets a little pricey. But if you're relying on your HD signal, then it's actually a small price to pay, I guess.
And to be clear, the boosters are not receiving a signal over the air and just rebroadcasting it. They are regenerating digitally from a digital source the signals, the analog and HD sidebands that need to go on there, correct?
Right.
Yes.
Yeah, we've done it in analog. I mean, we've done it over the internet. Ideally, it would be nice to have a microwave, point-to-point microwave, or a dedicated IP circuit. But actually, in most of our installations, it's being done on a really good internet connection.
Fiber,
between
usually
main and the studio. Yeah, fiber preferably.
Yeah. Is there any kind of orchestration software, any kind of monitoring software that can look at the different sites and check and make sure that they're still operating the way you intended? Or is it a matter of going out in the field and remeasuring or something?
Well, all of the equipment that we have has SMTP monitoring, and in fact, in the one system we're putting in San Francisco, that'll be entirely monitored with, if something goes out of tolerance, it will let us know. And the system also monitors itself, because if something does go out of tolerance and your timing is off, you're just better shutting off the booster rather than just generating interference, because it can go from 0 to 100 really fast.
Yeah.
Gotcha.
So the IP links, monitor the time offset and give you an idea when things are starting to, if you're starting to get a lot of network errors. We also generally put an off-air receiver in Avonics, off-air receiver that, is web enabled. So you can actually go listen to the booster. If you're running HD, like Bert says, it can compare analog and HD to make sure the time alignment is right. Because one of the things that can happen is if you lose some bits in the transport, the HD can get out of time on a specific booster, so it starts slipping the time alignment. So we try to have a closed loop where you're actually monitoring the end product, so you're fairly certain that it's not causing a problem.
Guys, we're going to take a quick break, and when we come back, it's time for usually our tip of the week. But Bert and Rich, maybe you'd like to address. We haven't talked much about the financial benefits of what a station
Sure.
can sell with 1 million more listeners. Maybe you've got that kind of information to get us salivating about actually making some more money, or maybe you've got some other tip for us. And Chris Tarr always has a tip for us as well. So we're going to take one last break here. This Week in Radio Tech, episode 585, with Bert Goldman and Rich Redmond, and of course Chris Tarr, my co-host. Brought to you in part by our friends at Angry Audio. The website is angryaudio.com. And we were talking about, if you learned about FM boosters back in the late 1980s like I did, your information's out of date. Well, here's something that was invented, I guess, in the 1990s, and that is the famous Studio Hub adapters. So many pieces of equipment from Axia, from WheatNet, from Ravenna, from others. They're using RJ45 connectors to carry analog audio or AES-EBU digital audio. I mean, they're gold-plated connectors. They're inexpensive. They're extremely reliable. But you know what? Your reel-to-reel machine, your CD player, lots of other equipment, maybe your audio processor still has XLR connectors on it. So you need an adapter to go between these, and this is the ideal adapter to do that from Studio Hub. And Angry Audio bought Studio Hub lock, stock, and barrel. They've got all the original jigs. They've got the people who knew how to make this stuff. It's not always easy to get these really nice audio cables to go into an RJ45 connector and crimp down properly. They perfected that, and they're still doing it right now. And you can buy them in that format. You can also get them with a male RJ45 going to XLRs or quarter-inch tip ring sleeves. But let's fast forward to today's technology, and look at this. This is what we've needed for years, the headphone disc connector. You got one of those disc jockeys that always gets up and forgets that he or she's wearing his headphones. Well, no more broken headphone jacks, because the headphone disc connector will just take care of that for you. It's like a MagSafe connector, right? And it just goes right back together. By the way, you can't reverse left and right. It won't go back together. It always goes back the correct way. That's the headphone disc connector. It's available in the quarter-inch tip ring sleeve or the 3.5 millimeter tip ring sleeve connector. So you can also mix and match these. How about that? Thanks a lot, Angry Audio. The website's angryaudio.com. Check them out and buy their stuff from your favorite dealer. Be sure you ask for Studio Hub exactly. That's the first quality stuff. It always works so well. Hey, This Week in Radio Tech is brought to you also in part by my friends at Max Connect Wireless. I'm about to get one of these for one of my transmitter sites. Check out this quick testimonial.
I'm Gary Morrill, Midwest Regional Director of Engineering for Alpha Media. When I first spoke with Josh Bone about Max Connect, he told me they'd work great for remote transmitter sites where connectivity was a challenge. And he's absolutely right. We even have sites where we're using this as a backup to our STL using Max Connect's dual carrier option, and it works perfectly. We also have times where we need to be able to get out to a venue where it's kind of challenging because everybody and his brother is trying to stream video at the same time, like at a big sporting event. And you know what? Our data gets through every time because it's prioritized packet data. It works for us. It'll work for you. Max Connect. Check it out.
Thanks a lot, Gary. And I've got one of those right here. This is the PepWave model, but they also have a cradle point model. And of course, the 4G LTE modem is not what matters. It's the SIM card that goes inside, because Max Connect Wireless has agreements with all the big wireless carriers, your favorite ones, and or the ones you hate the least, and they'll give you prioritized data and a fixed IP address. By the way, one of my transmitter sites, there's the website there, Max Connect, spelled funny because that's the internet these days, .com. Hey, one of my transmitter sites, it's an AM site in not the best part of town. We just got a quote to bring fiber internet to that transmitter site. And you know what the quote was? $2,150 per month. Yeah, that's what they wanted to bring fiber out there. Again, it's not a great neighborhood, and that was the charge. Well, we're not going to do that. We're not spending over $2,000 a month for internet at that site. So Max Connect Wireless is in the running. I'm probably going to be the solution right there, because we just have some simple needs out there: Burke remote control, a Wise camera, and an IP phone, and maybe some backup STL, because we've got a 950 megahertz. STL. Thanks a lot, Josh Bone, Max Connect Wireless. All right, we're going to wrap it up here with Bert and Rich talking about geo broadcasting and max casting. So, gentlemen, what would you like to close the show out on here in terms of advice?
Well, Rich, I think you had some. You may have some financial information as far as what this can do for ratings and revenue and such.
Yeah. So Bert showed the stations in Boston. So Boston, incidentally, we've done 3 stations: WXLO, which he showed you, an independent WXRV, and then one of the EMF stations. The independent guys and Cumulus both saw fairly significant growth in ratings and in revenue. So I think the Cumulus guys were in excess of 20% revenue growth after implementation, and WXRV was a little bit higher. They were near 40%. And it really came down to, in their case, getting credit for the people who were listening in areas where the meters didn't, the PPM meters didn't give them the correct attribution, and allowing people to listen in areas they couldn't before. Good coverage isn't going to make up for, programming, but for sure, if somebody can't hear you or the people meter can't decode, you're not going to get credit. And so the payoff is pretty significant.
Wow. That's that.
Yeah, and as you might expect, the Nielsen's gives you some expectation of PPM recovery that may be a little different from what actually we're finding in the field.
Yeah. You guys mentioned the first look is free. So if a station is thinking, I wonder if we'd be helped by program, providing areas of perhaps different commercials, different narrow casting to a neighborhood where we happen to have put a booster. Tell us what you guys can do for a station that's thinking this might be something for us.
Well, just to be clear, the platform of doing single frequency networks or boosters has a couple of different applications. The one that we're mostly talking about here, we call max casting. It's really about signal enhancement, fully authorized by the FCC, and you could deploy it tomorrow if you wanted. There's another version that you've alluded to, Kirk, which is, we can then take these cluster of boosters, and you could potentially put different content, potentially narrowcast advertisement in a certain area. So for example, if you wanted to break up your newscast and have a different newscast on the west side of the market versus the east side, or if you were talking about commercials, one of the things that we found is most of the time people buy from local businesses within a certain number of miles from their home. And you think of a big market like in LA or a Dallas, it's unlikely somebody's going to drive 60 miles across the Metroplex to go buy a car from a different Ford dealer, right? So the ability to have ads in a certain neighborhood are what the product's called zone casting does. Now that's right now, going through rulemaking at the FCC. The commissioners voted 5-0 to approve under a notice for proposed rulemaking, and GeoBroadcast has submitted a bunch of technical evaluations to the FCC, and so it's in the rulemaking process. So we're optimistic that that's going to get approved, and that could be a future application. But today, the thing you could deploy today is fully authorized, is really about maximizing within your contour to make sure you reach everybody you should be covering. And
I can imagine
the first look is free.
Yeah.
To your point, if somebody's interested, go to the website, geobroadcastsolutions.com. You can go into the submit a question or whatever, the contact us, and reach out, and one of us will follow up with you. And generally what we'll do is take a look at your station. We'll run some maps, and you kind of give us some guidance of areas that are important to you. We'll see what it looks like, and then we'll do a quick look to say what a couple of boosters might look like, and give you an idea of what the population growth might be.
Perfect. And I'll put those links in the show notes. Chris Tarr, I know you usually have a quick piece of advice for us. And Chris, I was just thinking about how zone casting could help you right there in Mukwonago, because people do like to shop locally. You could run ads. You could override the ads, in the rest of the market, and you could advertise Chris Tarr's Tavern, Tea Shop, and Tarantula Supply, just to your neighborhood, because nobody's going to drive very far for that. But you could have that right there in your neighborhood.
Oh, Kirk. So my tip this week, really quickly, and it touches on some things I've brought up before. A lot of the big groups are doing this now, where they're consolidating, transmitter readings into TOCs and things like that. It's no longer for the big guys, thanks to SNMP and the proliferation of VPN hardware. All of my sites now, all of the transmitter sites have VPN firewalls. I've tied them all together, and thanks to SNMP, I now have one master Burke remote that monitors everything. Now I have backups for all that stuff, but I can log into my main Burke remote control, and I can see all the readings from all of my transmitter sites all over my markets. And that is all thanks to the fact that everything is on now one network in our facilities. So with the, even though we're on different physical networks, thanks to VPN, everything is pooled together, and I can pull that data from across different markets. But it's gotten to the point where it's inexpensive enough for small stations to do. I'm buying the appliances off lease for, I believe, it's SonicWall, and I believe it's right around $300 or so per market. So, it's something that iHeart and Odyssey have been doing for a while now, and a lot of smaller stations, but I would love to do that. Well, it's gotten to the point now where it's within reach, and so you might want to start looking at that.
Great idea. Great idea. VPNs all the way around. We got to go. Thanks a lot to Suncast for producing today's show. I want to say a big thank you to Bert Goldman. Thanks for taking your many years of expertise and applying them to this kind of technology here. Bert, good to see you. Thank you. And also Rich Redmond. Thank you for being here, Rich, consulting the broadcast industry on so many things, this being one of them. Glad you're here, Rich.
Thanks for having us.
Yeah. Thanks, Dan. Thanks for the idea of doing the show about this. It's high time that we did, and I'm glad that's a good time to do it. We'll have show notes. We'll have links to these things in case you missed one. You can click on the show notes. Go to thisweekinradiotech.com. And of course, you're always welcome to leave, send us a message, leave us a note there as well. And if you would, go like us on Facebook. We have a page on Facebook, This Week in Radio Tech. And on YouTube, if you'll go to YouTube and just subscribe to the show there, that would be great. You'll get notified automatically. About a day later, after we do the live show, Suncast posts the recording of the show up. We cut out all the mistakes, and it's just the good stuff we put on. Sometimes the show's a little shorter too on YouTube. So look for This Week in Radio Tech on YouTube. We got to go. Chris Tarr, thanks for being with us, buddy. Appreciate it. Good to see you. Chris Tarr has a tower story for us next week, so you don't want to miss it. That'll be next week on This Week in Radio Tech. We'll see you next week. Bye-bye.